Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2021, paper 1. In today's lesson, we will start from question number 16 and we will talk about mechanics and waves questions. As always we will discuss these questions in detail so you can improve your conceptual understanding of these two topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 16 says a gas is contained inside a syringe as shown in the figure. The initial volume of the gas is 2.0 centimeters cube. Atmospheric pressure is 101 kilopascals. We need to find out what is the work done by the gas on the atmosphere when the gas is heated and expands to a volume of 6.00 centimeters cube. So very basic question. In this case, gas is expanding, so it simply means that work is done by gas. So simply we can write down work done by gas. Work done by gas, this is equal to P times delta V, and this formula you can only use if P is constant. So this quantity has to be constant, then you can use this formula. If P is not constant, you can not use work done is equal to P times delta V. But at AS level, most of the time you can use simply work done is equal to P times delta V. So we have value of P, that is 101 times 10 to 3 pascals, and we have change in volume, that is 6.00 minus 2.00, and this is multiplied by 10 to minus 6 because we have to convert unit into SI unit. 1 centimeter, you need to understand, this is equal to 10 to minus 2 meters, and 1 centimeter cube, this will be equal to 10 to minus 2. You have to take cube on this side as well, so this will be equal to 10 to minus 6 meters cube. So that's the reason we multiply with 10 to minus 6. Now if we simplify this one, if we just multiply, we will get 404 times 10 to minus 3. So it simply means this is equal to 404 millijoules. So the answer for this question is B. Quite straightforward question. Simply you need to understand work done by gas is P times delta V. If expansion, work done by gas is positive. If it is compression, work done by gas will be negative because this quantity then will be negative. Mean the change in volume will be negative, means the volume will decrease. So the answer for this question is B. Question 17 says a mechanical device does useful work at rate X and waste energy at rate Y. Which expression gives the efficiency of this device? So first of all, you can imagine this is the device. In this case, useful energy is X, then the wasted energy, this is Y. So the input in this case has to be equal to X plus Y. We need to find the efficiency, so efficiency simply has to be equal to P out. Useful, very important one, you need to understand which power you have to take. Useful divided by P input, total input energy. So in this case, useful we have, that is X, and the total input is X plus Y. So the answer for this question has to be C. So this is important point. You have to take useful energy output or you have to take useful power output, and this one has to be the total. It means this has to be useful plus wasted, useful plus wasted. So very important one. So the answer for this question is C. Question 18 says car P has kinetic energy of 240 kilojoules. Car Q has half the mass and twice the speed of car P. What is kinetic energy of car Q? So the best way to answer this question, first of all, we can say kinetic energy of car P, this is equal to 1/2 mv square, and this is equal to 240 kilojoules. And kinetic energy of car Q, we can say this is equal to 1/2 m by 2, and the speed is double, so we have 2v square. Now we can simplify, so we can write on 1/2. Here we have m by 2 and here we have 4v square. From here we can cancel this 2 with this, so we will get 2 here. So if we simplify, we can write down this is 1/2 mv square multiplied by 2, and 1/2 mv square, this is equal to 240. So 1/2 mv square, this is equal to 240 kilojoules. So we can replace this one with 240 kilojoules, and this is multiplied by 2. So our final answer in this case will be 480 kilojoules. So the answer for this question is C. Question 19 says a water pump is driven by an engine. The pump raises a volume of 0.50 meter cubes of water in 1 minute from a depth of 30 meters. The pump has an efficiency of 70%. The density of water is 1000 kgs per cubic meter. What is the useful output power from the engine? Tricky question, but beautiful one. So let's look at this one. First of all, we can simply imagine we have engine. So you can simply write down this one is engine. This engine is driving a pump. So we can write down here, this is representing a pump. So we can say this is pump. So there is input power to the engine. So engine has some input, and then engine has output. So we are talking about useful output of engine. So this is useful engine output. So we can say useful output from engine, and here we have useful output from pump, useful output from pump. So in this case, so the output, useful output from the engine, so we can write on here, in this case useful output from engine, this is equal to the input. So this is equal to input of the pump, input to the pump. So we can say input of the pump, or simply you can say input. So this is input of pump. So here we have input. So this is what we need to calculate. Question is asking us to calculate useful output power from the engine. So it means we need to calculate input power to the pump. Input power we need to calculate, but in this case we have useful output power for the pump. So we can write down useful output power for the pump. So here we are talking about pump. So we are talking about pump, for the pump, and that will be equal to mg delta H divided by delta T. So in this case, mass is equal to the volume. So we have volume, we can write down here, the space is not enough, we can simply write down here. So we have volume that is equal to 0.50, and we have the density of water that is 1000, and the depth is 30 meters, means this is the height, and the time is 1 minute, means 60 seconds. Mass is equal to density time volume, very basic concept. Now this is our useful output power, and how we can find out the input power. So we will be writing here input power to the pump, input. So the input power, you need to understand the efficiency. This is equal to useful P out over P in. So here we have P in. So the P in, this has to be equal to useful P out divided by efficiency, means in this case we have 0.70. So simply we can write on here, we have 0.50 multiplied by 1000 multiplied by 30, and this is divided by 60, and we need to divide this whole by 1 by 0.70, and if we solve this one, we will get our final answer, that is 3.5 kilowatts. So this is how you can figure out. This question is pretty straightforward. Only the tricky part is this one. So this is the tricky part. This is the tricky part. You need to understand useful output from the engine is equal to input of the pump. So this is the important point. Then this is just simple basic calculation. I hope this point is clear to you. So the answer for this question has to be B. Question 20 says, which spring combination has an overall spring constant of 8.0 newtons per meter? If you look at option A, we have two springs and these two springs are connected in series. And when springs are connected in series, they experience the same force, because in this case we assume spring is massless. So the force on spring 1, we can say this is spring 1 and this is the second spring. So the force on second spring is 1.6 and force on first spring also will be equal to 1.6 newtons. So we can find out value of K. So in this case K1 will be equal to K2 because the same extension, same force. So we can find out value of K. K will be equal to force divided by extension, that is 0.20. So this is equal to 8.0 newtons per meter. So this is value of K. So we have K1 and we have K2 and these two springs are connected in series. So in this case K effective, this one has to be equal to spring constant of one spring divided by number of springs. For identical springs you can use this one, spring constant divided by number of springs if the springs are connected in series. So it means overall spring constant is equal to 4.0 newtons per meter. So this combination is not possible. Now if we go to the second combination, in this case we need to understand these two springs, they are connected in parallel. So it means that the force acting downwards, this force is 1.2 newtons and there are two forces acting in upward direction. So this is the spring force. So this spring force has to be half, mean this one is 0.6 newtons and this is also 0.6 newtons. So in this case force is divided when the springs are connected in parallel. So this is the main point you need to understand, or simply you can understand this is 1.2 and two springs they're pulling up, so the force will be divided because they are identical springs. So we can find out value of K. In this case we can say K will be equal to 0.6 divided by 0.075. So if we solve this one, we will also get this is equal to 8.0 newtons per meter. And these two springs, they are connected in parallel. So the K effective in this case, this will be equal to K1. We can say this is K1, this is K2. So it will be equal to K1 plus K2. So we have 2 times 8.0, it means this is equal to 16 newtons per meter. So this is also not possible answer. Now if you go to the next one, in this case we have one spring here and these two springs, they are connected in parallel, mean these two springs are connected in series with this. So the force on this spring, we can say this is spring 1, this is spring 2 and this is spring 3. So if you look at spring 3, we can write on K3 for this one. This will be equal to 1.8 divided by 0.15. If we solve this one, we will get this is 12 newtons per meter. And value of K1 will be equal to K2 because they have the same extension and also they experience the same force. The force on this one will be half of this force because force will be divided when the springs are connected in parallel, as we have discussed here. So in this case, if we want to draw the free body diagram on this rod, so we have 1.8 newton force that is acting down and there is 0.9 newtons acting up and we have another force of 0.9 newtons, this is acting up. So spring constant in this case simply will be equal to 0.9 divided by 0.075. 0.075. If we solve this one, we will get again this is 12 newtons per meter. So first of all, we can find the K effective for these two springs. Mean we can replace these two springs with one single spring, and for that spring we can find out K effective for parallel combination. So I will be writing here K effective, KE. So this KE, they are connected in parallel, so this has to be equal to K1 plus K2. So in this case we will get 24 newtons per meter. So this is the K effective for these two springs. So this is K effective when these two springs are connected in parallel. So these two we can replace with one spring of K equal to 24 newtons per meter. So we have 24. If we redraw this one, so this is the situation now. We have one spring here and we have an other spring here. So this is an other spring. Spring constant for this one, we have K, that is equal to 12 newtons per meter, and we have K for this, that is equal to 24 newtons per meter. So we can find out K effective. They are connected in series, so the K effective in this case has to be like resistors connected in parallel. So it means 24 multiplied by 12 divided by 24 plus 12. So if we solve this one, we will get 8.0 newtons per meter. So this is how we can answer. So this is our final answer. The question was asking us to find out combination which has overall spring constant of 8.0 newtons per meter. It means answer for this question is C. You can also check option D by yourself using the same principles. You will see answer will not be equal to 8.0. So the answer for this question is C. A very nice question on springs combination when springs are connected in parallel and also in series, and the combination of parallel and series. A beautiful question to practice on this topic. Question 21 says a metal wire is stretched to breaking point and the force extension graph is plotted. Which graph is correctly labeled with the elastic region, the plastic region, and the area representing the work done to stretch the wire until it breaks? So if you look at option A, elastic region, yes, force and extension, they are directly proportional, so this is right. Plastic region, this is right. Work done is not right. Work done has to be the total area under loading curve, so it means this one is incorrect, so option A is not possible. If you look at option B, so this is representing plastic region, this is incorrect. This has to be elastic. This is elastic, it has to be plastic. Work done, yes, this is the total area under loading curve, so this is right. If you look at option C, plastic region, correct. Elastic, correct. Work done, no, this is incorrect. This has to be the total area, so this is also not possible answer. If you look at option D, we have elastic region, plastic region, yes. Work done, yes. So the answer for this question is D. Total work done is the total area under loading curve. So the answer for this question is D. Question 22 says a longitudinal wave travels along a long spring. The spring is shown at one instant. What is the wavelength of the wave? So here we are talking about the wave. So wavelength is the distance between two consecutive points in phase. So in this case, simply we can say this will be the distance between two consecutive compressions. So these are compressions, and here we also have compression. So if you look at the first one, this is the distance between center of one compression and next one is the rarefaction. So this is rarefaction, this is also rarefaction. So this distance is equal to lambda by 2, and this is distance between two consecutive compressions, so this distance is equal to 1 lambda. So the answer for this question has to be B. And if you look at the next one, this will be equal to 1.5 lambda, and the next one, this will be equal to 2 lambdas. So the answer for this question is B. Question 23 says which statement about waves is correct? If you look at option A, it is given to us both longitudinal and transverse waves can travel through a vacuum. Longitudinal waves means sound cannot travel through vacuum. So it means option A is not possible. Option B says both longitudinal and transverse waves transfer matter. Waves only transfer energy. They do not transfer matter. So it means B is also incorrect. Longitudinal waves, progressive waves consist of alternate nodes and antinodes. Stationary wave, they consist of nodes and antinodes, but longitudinal waves do not consist of nodes and antinodes. So this is also not possible answer. The particles of a transverse wave vibrate perpendicular to direction of energy propagation. This is correct. So imagine that transverse wave is moving to the right, so energy will be transferred to the right. So this is propagation of energy. And we can also imagine a particle of medium, and this particle of medium, this will vibrate perpendicular to energy propagation. This angle will be 90. So this is how the particle of medium, they will vibrate like this, and the wave will move to the right or to the left. So the answer for this question is D. Question 24 says a stationary sound wave is formed in a pipe that is closed at one end and open at the other end. The wave has two antinodes. One of these antinodes is at the open end of the pipe. The length of the pipe is 0.60 meters. The speed of the sound in air column is 340 meters per second. We need to find out what is frequency of the sound wave. So first of all, we can simply draw one pipe. So this is the pipe. And for this question, it is given to us at the open end, there is antinode. So we can write down this is antinode. And at the closed end, there will be node. So we can label this is node. And it is given to us there are two antinodes. So we can also imagine here we have one node. So here will be an other antinode. Now simply we can draw the stationary wave. So if we draw stationary wave, in this case our stationary wave will look like this. So here we have antinode. So in this case the length of the pipe is given to us. So this is the length of the pipe, and this is equal to 0.600 meters. So this is the length of the pipe. We can also clean little bit here so it looks better. So in this case, how many lambdas we have inside? So this is lambda by 4, and distance between two consecutive node and antinode is lambda by 4. So this is also lambda by 4. So it means in this case L is equal to 3 lambda by 4. Simply we can say lambda in this case is equal to 4L divided by 3. Value of L we have, that is equal to 0.600 divided by 3. So if we solve this one, we will get 0.80 meters. So this is value of lambda. Now we need to find out frequency. So frequency will be equal to speed of the wave divided by wavelength of the wave. So speed is 340 meters per second. Lambda is 0.80. So if we solve this one, we will get our final answer, that is 425 hertz. So the answer for this question is A. A typical question. So the main concept is this one. This is the main concept, and you need to understand how to draw the stationary wave, and then you can figure out value of lambda. Question 25 says a train travels at constant speed along a straight track. The train's horn emits sound of frequency 500 Hz. A person standing by the side of the track hears sound of frequency 450 Hz. The speed of sound in air is 340 meters per second. What is the speed of the train, and in which direction is it traveling relative to the person? So this question is basically about Doppler effect. So in this case we have frequency of the source, that is equal to 500 Hz, and observed frequency, in this case we have 450 Hz. So in this case observed frequency, this is lower than frequency of the source, it means in this case source is moving away. So we can say source is moving away. So this is first thing we can infer, source is moving away. So it means B is not possible answer and D is also not possible answer. So answer can be A or answer can be C. Now we need to use Doppler effect equation for a source moving away from observer. So we have F naught, this has to be equal to V, speed of the wave, divided by speed of the wave, plus speed of the source. Speed of the source. So we have speed of the source multiplied by frequency produced by the source. So in this case we need to find out Vs. So we can write down here, we have F naught times we have speed of the wave plus we have speed of the source. This one has to be equal to frequency of the source multiplied by speed of the wave. So for this question we need to find out speed of the source. So we can rewrite here, we can say speed of the wave plus speed of the source. This has to be equal to Fs, speed of the wave, divided by observed frequency. We are interested in Vs, so this has to be equal to Fs divided by F naught. So we can write down this one in a proper way, so divided by F naught. So we have divided by F naught multiplied by speed of the wave plus, this is plus, so this side this will be minus, so we can subtract speed of the wave. So here we have speed of the wave. Now simply we need to plug in values and we can find out speed of the source. So we have frequency of the source, that is 500, observed frequency we have 450. We have to multiply this one with speed of the wave, that is 340 minus 340. If we solve this one we will get 38 meters per second. So 38 meters per second. So the answer for this question has to be C. So C is the answer. So this is how you can approach a beautiful way, nice question about Doppler effect.